This film is intended for young people or people not knowledgeable on the subject as an introduction onto how things work. There'll be loads and loads of real experts out there who will know far more about engines than I do, and if you want to comment, that'd be absolutely fantastic. Now, this might sound really obvious, but I'm going to say it anyway. You have to understand that these bits have been actually sawn away. In here, I've got the bit that I actually took out, just so you're under. You might be thinking, well, how does that all happen? It's not airtight, is it? And likewise, these bits here were all sawn away to expose the working parts. Well, I know that sounds obvious, but I'll just say it, okay? This is a very simple engine. It's off of a lawnmower, and it's what we call a side valve. Now most modern car engines have the valves coming in from the top here, and a really posh engine would have what we call a double overhead cam, with the cams that lift the valves, which you can see are down here on this model. I don't know if you can see them inside. Just turning over the cam followers. That camshaft will be up here, and there'll be two of them. Double overhead cam. The 4-stroke engine provides power on only one of the 4 strokes. This is a stroke as the piston comes down, it draws in the fuel air mixture. On its way up, it compresses that mixture. At top dead centre, the spark plug ignites the fuel air mixture, and the expanding gases force the piston down. This is the power stroke. The piston then travels up, and the exhaust gases leave the cylinder, and the whole process starts again. Induction, compression, power, exhaust. It's a single cylinder, 4-stroke internal combustion engine, and the main difference between this 4-stroke and the 2-stroke is that it has valves in here. These are the valve springs. At the top here, you can probably see the valves opening and closing, or one valve. You'll see the valves here opening and closing as I turn over the engine. There you go. That is the inlet valve. Okay. And that one inside is the exhaust valve. Now, I don't know if you noticed that on one of those passes by the piston, nothing happened to the valves. They didn't move at all. So the way it works is, let's get it timed up properly. Okay, right. What we want to do is we want to be coming like this. Over again. Right. See, the piston there is coming up to top dead centre, and it opens the inlet valve. Now, as the piston goes down, so the valve open there, the piston's going down there. Atmospheric pressure causes the fuel air mixture to be drawn into the cylinder. Then the piston goes up to top dead centre, compressing that mixture because both the valves are closed. The spark plug will fire here, igniting the mixture, and the burning expanding gases will push the piston down. And this time when it comes up, oh look, you can actually see already that the exhaust valve is open on the start of the exhaust stroke, and you can just see it closing there, and the whole cycle starts again. See, look, the exhaust is closing, the inlet's opening, and the piston is going down to draw in the mixture. These various fins offer cooling. This is an air-cooled engine as opposed to water-cooled. What happens is that on one of these shafts here there would be a fan mounted, and it would blow air across those fins, and the heat would transfer to the air and be taken away. As I rock the crankshaft backwards and forwards, you can probably just see the cam in there acting on the cam follower, which in turn is compressing the valve spring and in turn causing the exhaust valve to open. Okay, that's how it all works. This is the crankcase here, and you can see the actual crankshaft turning over there. There's the piston coming down, and there's the crankshaft. Now, this engine is lubricated by a store of oil that's kept in here, which is called the sump, and it's on this very crude basic engine, it's just really thrown around the engine to lubricate the cams and the walls of the cylinder. You'll hear people talking about the size of an engine. They might say, it's my car is a 2 litre, or my bike is a 500cc. Now that's a measure of volume. cc stands for cubic centimetres, and the measurement comes from the sweep of the piston. So that's at top dead centre. So when it comes down to here, okay, and it starts to return, that is the sweep of the piston from there to there. Now on this engine, I reckon that's probably around about 50 cc's. One aspect that fascinates me about internal combustion engines is that they can be scaled up to an absolutely gigantic size. Now an example of this would be an oil tanker or a cargo ship. Now how big do you think they get? Big as this room? No, bigger. As big as a house? No, bigger. Big as a small block of flats. Go onto the internet, have a search for large diesel engines or marine engines, and you'll see them. Absolutely fascinating. And basically, all they are is a scaled up version of this. A crankshaft, a piston, a cylinder, and some valves.